Hello guys, welcome aboard Apex Math. My name is Pino. In this video, we go through question 1 from the July 2025 N6 Mathematics question paper. Question 1.1 states that the sides x and y of a right angle triangle are 2 millimeters and 3 millimeters respectively, with the hypotenuse as r. We are to calculate the approximate change in length of the hypotenuse if x changes to 3 millimeters and y changes to 5 millimeters. Since we have three variables, the x, the y, and the r, and they are all changing, we are not going to talk about the normal derivative that we are used to. Instead, we are going to talk about the partial derivatives. So we have the original triangle where the x, the side x, was equal 2 millimeters. So we have 2 millimeters as our x, and our y was originally 3 millimeters. So our y is going to be 3, and we are told that the x changes to 3 millimeters. So our x changes from 2 millimeters to 3 millimeters, while our y changes to 5 millimeters. It moves from being length 3 to length 5 millimeters. Our original hypotenuse was r, so let's calculate the change in y. So we have the change in y, which will be equals to y final minus y initial, and our y final is equals to 5, and our y initial is equals to 3. So our change in y will be equals to 5 minus 3, which is equals to 2. And on the other side, we have the change in x, which will be equals to x final minus x initial. And our x final is equals to 3 millimeters, and our initial x was equals to 2 millimeters. So change in x is 3 minus 2, which is 1. You can always use x2 minus x1 and y2 minus y1 instead of the final and the initial as our subscript. Now we have to link the x, the y, and the r using the theorem of Pythagoras. So we have r squared is equal x squared plus y squared. We differentiate partially, so the partial derivative of r squared will be equal to 2r multiplied by the partial derivative of r, and the partial derivative of x squared will be 2x multiplied by the partial of x, plus the partial derivative of y squared will be 2y multiplied by the partial derivative of y. Now we want the change in r. So to determine the change in r, we divide both sides of the equation by the 2r so that we can make the partial derivative of r the subject of the formula. So that 2r and that 2r will divide to 1, and the change in r, or the partial derivative of r, will be equals to 2x multiplied by the partial change in x plus 2y multiplied by the partial change in y divided by the 2r. Let's copy and paste this triangle. In the place of that x, we'll substitute the 2. In the place of that y, we substitute the 3. We have to determine the r so that we can substitute the r in the place of that r. So we have r squared is equal x squared plus y squared. R squared will be equal to, in the place of the x, we substitute the 2, and in the place of the y, we substitute the 3, and r squared will be equal to 2 squared, which is equal to 4, plus 3 squared, which is 9. 4 plus 9 is equal to 13. So our r will be equal to the square root of 13. So in the place of that r, we'll substitute 13. And remember, we determined the partial change in x and y. So remember that at the top here, this change in y is actually the partial derivative of y, and this change in x is the partial derivative of x. So we'll substitute them there. So the partial derivative of r will be equals to 2 multiplied by, in the place of the x, we have that 2, and the partial derivative, in the place of the partial derivative, we substitute the 1. The partial derivative is the change in. So the change in x is 1 plus 2 multiplied by our y, which is 3, and the partial change in y was the 2. So in the place of the partial derivative of y, we substitute the 2. This is divided by the 2 multiplied by r, but we determined that our r was the square root of 13. Now the partial derivative of r, or the change in r, will be equals to 8 times the square root of 13 divided by 13, and in decimal form, the partial derivative of r, or the change in r, will be equals to 2,219, and this will be our answer for this first question. Moving on, question 1.2, we are given the following parametric equations: x is equal to t minus t squared and y is equal to the ln of 3t. 1.2.1, we have to determine the derivative of y with respect to the derivative of x, which will be equal to the derivative of y with respect to the derivative of t, all divided by the derivative of x with respect to the derivative of t. Let's start by determining the derivative of x with respect to t. So we have x is equals to t minus t squared. So the derivative of the x with respect to the derivative of t will be equal to the derivative of t, which is 1, and the derivative of t squared, which is 2t. And now let's determine the derivative of y with respect to t. So the derivative of y with respect to t will be equal to, so we are going to take the function which is inside the ln and put it in the denominator, and this function which is inside the ln, the 3t, its derivative is 3, which we put in the numerator, and 3 divided by 3 is 1, so we have 1 divided by t. So the derivative of y with respect to t, so we can see that the dy over dt is at the top. So dy over dx will be equal to, so since the dy divided by the dt is at the top, we are going to take the 1 divided by t and put it in the numerator. And in the denominator, we have the dx divided by the dt. The dx divided by the dt is 1 minus 2t. Let's rearrange so we can express this as 1 over t divided by 1 minus 2t. This will be equals to 1 over t, and we change that division sign into multiplication, and that is divided by 1. When we change this into multiplication, it will reciprocate. The 1 will be the numerator, and the 1 minus 2t will be the denominator. Our dy divided by dx will be equals to 1 divided, we can distribute the t, so the t multiplied by that 1 will be equals to t, and the t multiplied by the negative 2t will be equals to negative 2t squared. Question 1.2.2, we have to determine the second derivative of y with respect to x, and for the parametric equation, it's defined as the derivative with respect to the derivative of t of the derivative of y with respect to the derivative of x, and this has to be divided by the derivative of x with respect to the derivative of t. We already have the derivative of x with respect to t as 1 minus 2t, and the dy divided by dx, we determined it as 1 divided by t minus 2t squared. So now let's substitute. So the second derivative of y with respect to x will be equals to the derivative with respect to the derivative of t of dy divided by dx. Dy divided by dx was the 1 divided by t minus 2t squared. And this is divided by the dx divided by dt. Dx divided by dt is equals to the 1 minus 2t. This d divided by dt simply means that we have to differentiate the 1 divided by t minus 2t squared. So let's go and differentiate it by the side. So we have to differentiate this, and we have a quotient, so we are going to use the quotient rule. So we take the denominator, the t minus 2t squared, and we square it. And then we also have to differentiate the numerator. So the derivative of that one will be 0. We multiply it with the denominator, the t minus 2t squared, minus the derivative of the denominator, but we have to multiply it by 1, by that 1 in the numerator. The derivative of the t is 1. The derivative of 2t squared will be 4t. So we have 1 minus 4t. So that 0 will nullify the t minus 2t squared, and we'll be left with negative into 1 minus 4t divided by t minus 2t squared, all squared. We can say we distribute that negative. So let's distribute that negative. So negative multiplied by 1 will be equals to negative 1, and negative multiplied by negative 40 will be positive 40, and we are still dividing by t minus 2t squared, all squared. So we can copy and paste this. So the second derivative of y with respect to the second derivative of x is equal. So we paste the numerator, and then the denominator is still the 1 minus 2t. So for the numerator, we already differentiated at the bottom. So the second derivative of y with respect to x will be equal negative 1 plus 4t, all divided by t minus 2t squared, all squared. We change that division into multiplication, and remember we are dividing by 1, so this will reciprocate as we change the division into multiplication. So the 1 will be the numerator, and the 1 minus 2t will be the denominator. So now the second derivative of y with respect to the second derivative of x will be equal negative 1 plus 4t divided by the t minus 2t squared, all squared, multiplied by 1 minus 2t. And this will be our answer for this last question. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.